Welcome, friends. It is week 2, lecture 2. We are continuing to talk about OOP today, object-oriented programming. Today is going to be a little bit more theory than it is actual coding. We're going to talk about it. Today's a little bit more for your understanding when it comes to like an interview perspective, right? And so one of the popular things in an interview, especially for somebody coming out of a boot camp, is they might ask you, what are the 4 pillars of OOP? What are the 4 pillars of object-oriented programming? So we're going to touch on that today. Before we jump into that, we're going to talk about chaining methods and association between 2 classes. And that's pretty much all we have. Chaining methods are fairly simple to kind of do and get caught up on, but we're going to walk through that. Also, same thing with association between 2 classes, maybe spend about 10, 15 minutes on that. And then we're going to really spend the rest of our time on the 4 pillars. I have some examples of some ones that are a little bit more challenging, in my opinion, like inheritance. That one's kind of like, wait, what? And so I have an example of inheritance that actually stemmed from our last class, and then talk through that. Before we get started, just some housekeeping. I will always do this every single lecture. Make sure you do your discussion posts. They are open. They are open until Sunday. There is no makeup. So make sure you go do those. Take about 5 minutes at max. You have to do 2 of them a week. So make sure you have done those, just as your friendly reminder. You also have 2 core assignments called bank accounts and users with bank accounts. Make sure you do those. They are going to be huge for just your understanding of classes. And you might leave this week, and then next week we're going to go straight into Flask, and you're going to say, okay, great, I'm in Flask. We're not using a class. And then the next week we're going to go to MySQL, and you're going to say, we're using a model, not really a class. I don't know. But then week 5 and 6 is when classes and everything comes together. So that is why we focus so heavily on OOP and classes and you understanding this material. I do want to also offer, I know that some people are struggling a little bit and struggling in the sense of, I think that you transparently, when you start a new language, it's very hard. And that's true. And I know that there are some people in the class that maybe have some background and have some understanding. And so it kind of seems like, well, compared to them, I don't know. I do want to offer that, if you guys need a one-on-one meeting with me, I met with a student yesterday and we just walked through some assignments. If that is the case, I would love to meet with you. I will put my Calendly link in the chat here pretty soon. And this is my personal one. I got to figure it out. Hold on one second. Calendly. And then you guys can meet with me if you need. If you guys are struggling, if you are, just needing a pep talk, I love to do that stuff. What I will ask is that I do meet a lot with students. And so if it's like, I just need help with my homework, please still utilize the main Python one. Or like a code review, please utilize that one because there's a ton of instructors. But if this is something that you need to talk with me, please feel free to use this one. And this is my calendar link. It's in the chat now. This is linked to my calendar, so it will give specifically me for a kind of a meeting if you need a pep talk or if you need just me to walk through some stuff. But I just want to encourage you, if you guys are still troubled with kind of functions, keep at it. I promise you, the more you practice, the more it will kind of come in handy. But if you do need to meet with me, feel free. That link is now in the chat. One other thing is next week we are starting Flask. So if we're just looking at the material, really excited to start Flask, but I would really hit these, really hit this Python fundamentals here. Dojo Pets is a great assignment that you can do. Hackathon is awesome if you have the time. If not, don't worry about it. But Dojo Pets is a great one to just continue to practice this. I wouldn't worry about this extras section at all. So you don't need to worry about this section. Then next week, we're moving straight into Flask. And so I have updated the readings for you guys. So it should be up to snuff. Everything should be good to go there. And so I'm asking you to read all the way up to static files, which is going to be this guy right here. So we're going to talk about really Flask, entering Flask, hello, talking about static files. And then following that, we're going to talk about forms and redirecting and session. And so read up to static files in Flask, and then we will get started there. Awesome. One thing I did want to point out is for the office hour, for the majority of the office hour, we did function practice. And so basically what we did, and it is recorded, but what we did is we walked through some of these functions, built them out together, did some pseudocode. So if you've never heard of pseudocode, I do explain kind of what we're doing here, just a way to think and approach different functions and questions. And then we did quite a bit to where we did one of the fun ones called FizzBuzz. And so that is in the, that will be, once I upload it, that will be here in the office hour right here. This guy will be a hyperlink, just like all the other ones are, just be a hyperlink to the office hour. If you want to go back and watch it, if you weren't able to make it, we do walk through some stuff, you know, conditionals and functions. And so if that is something that's struggling or a struggle for you currently, then I would encourage that. Any questions on this? Somebody said, I'm still struggling with functions. Do you have any recommendations to help learn those? Yeah, one thing I would suggest is you still have access to your web fundamentals section. Go into the JavaScript and there's this basic foundation optional assignment. You can do all of this in Python. So, you know, and there's a solutions thing. So obviously, you know how, like, you know, they might call it an array and we call it a list, but I would go and I would, again, practice these. I talked through functions in my office hours, so go watch that video. Practice these is where I got a lot of the questions that we went through, but just practice these, continue to practice them. And if you need, you're absolutely welcome to set up a one-on-one with me, or just even as a group. If you guys want to get together in Discord and say, hey, Will, at Friday at, you know, 3 o'clock, can you meet up with 5 or 6 of us? Yeah, absolutely. We can go and for an hour, walk through that stuff. So perfect. I told you guys, I will say that it is hard. I told you guys that it was going to be hard, but Peter did share this great video for me. I think you guys can hear it, but this, if this does not really like reiterate what development is like, then good to know. Let me know if you can't hear it.
Apparently,
Can you hear it? Okay, cool. All right, I'm gonna start it over.
apparently, Stucky being non-violent.
Dude, sucking at something, first step towards being sort of good at something. You
And that's true, right? Sucking at something is the first step at being sort of good at something. So it's a process, friends. It is a process. I'm currently in that. I'm learning some new material right now, and I've been developing for a while, and I'm there with you. Literally, I thought today, I'm like, oh, this is definitely what my students feel like, because I feel like, wow, what the heck? So if you're feeling that, know that you're not alone. And if you need anything, obviously feel free to reach out. You have my Calendly link. Let's meet and kind of walk through this stuff together. Any questions before I jump into the material? Cool. All right. So we have 3 main topics we want to cover today. This one by far is going to take the most time. So let's just jump into my chaining methods. Yep. Okay. Let's jump into my chaining methods. So this is something I built just preemptively for us. And before I do that, before we kind of jump into this stuff, I'm just going to do this. That's going to be for the second part, but this looks like something we've already done before, right? I've got a class of user. I have my dunder init, right? This is my initializing method. This user takes in a name, an email, in this case, an interest rate and a balance. We'll worry about that here in a bit, but all we're really focused on is a name and an email, right? Okay. So when I create this user, what's happening is I have to pass in a name and an email. Because these are default, it's okay if I don't pass them in, and I don't need them right now. So I'm just going to leave them. But what I really am focusing on is name, email, and account. So let's go ahead and create a user. So I'm going to say Chuck, which is my dog, equals user, right? I'm creating a new instance of my user. It says that I need a name. The name's going to be Chuck. And my email is just going to be c@c.com. Cool. So now if I were to say print Chuck.name, and I run this code, and this is just a recap. It's what we talked about last time, right? It gives me Chuck. I've got this instance of user called Chuck, right? And then I can refer to that specific instance here, Chuck.name, and it gives me that specific name. Now there's something called chaining methods. And if we're looking here, Chuck can make a withdrawal, right? Chuck can make a deposit and he can make a transfer. Now, normally what we did last time is we just had something like this, right? Where we just said make deposit. I'm just going to delete them actually. Make deposit and it did something. So I can say something like this. Chuck dot make deposit. I want to deposit a lot, 10,000. Perfect. If I were to say something like this, print Chuck dot account. Right. I want to print my account, which should be 0 at the beginning. Then I make a deposit of 10,000 and then I want to print my account again. And then that should say 10,000. So if I'm here, I say terminal. That's a bunch. And I say Python 3 main.py. So you see my account at first had 0, right? Because that's what it defaulted. I ran a method and then I ran the method make deposit where I added $10,000 to my account and then I printed again and then I see 0 and 10,000. Cool. Now there's something called chaining methods, meaning that we can add a method call on top of another method call. What do I mean by this? Let's say I wanted to make a bunch of deposits of $10,000, right? Instead of me having to do this on all these different lines, what I can do is I can chain them together. So called make deposit. Let's say 10,000. And then I want to do another one. Make deposit 10,000. Now, in order for this to work right now, if I were to do this, it's going to give me an error. It's going to say Chuck make deposit dot make deposit make deposit. None type object has no attribute make deposit. What happens here is when Chuck runs make deposit this first time, it will run this method, right? And it will add 10,000. But here on this make deposit, what this returns is a none type. It returns nothing, right? My method doesn't technically return anything. What I wanted to do is I wanted to emulate when we said Chuck make deposit 3 times, right? Chuck dot make deposit, Chuck dot make deposit, Chuck dot make deposit. So if I wanted to emulate that, all I have to do for a method to be chained, and this is what we call a chain method, is I have to return self. Once I do this, this is taking in self. So it's identifying Chuck, right? That specific instance of my user. It alters something or does whatever the method's supposed to do. And then what it actually does is it returns Chuck back, right? That specific instance. That's what it returns, is that instance of my user. Well, if we think about it, when this runs, right, it takes in Chuck and 10,000, runs it, changes Chuck's amount, and then it returns Chuck back, right? That specific instance. So that is like this is saying, now it runs that code and then it goes down and it says, well, Chuck, right? Because it's referring back to that same instance. So if I want to do a chain method here on my class, I have to always return self. As long as it returns self, I can chain. I can do make deposit. I can do make withdraw 10,000. Doesn't matter. Now, if I were to run this, Sorry, my computer was slow. It didn't save. Oh, no, it did. Because I deposit 10,000. I deposit another 10,000, which gives me 20,000. And then I withdraw 10,000. Therefore, my value is 10. I'm just going to put, let's just withdraw 1,000 so we can see a kind of a different number. Save it. Perfect. So now you can see it makes the first deposit, makes the second deposit for 20,000. It takes out 100. Therefore, my value is now 1990 or 900. That is what we call a chaining method. As long as I am returning self, I can stack them on top of each other. If I'm not returning self, I cannot do that. Any questions on chaining methods? Here's a great assignment that walks through it. So it says Guido, but you're just practicing doing the same thing, making sure that it returns self.
When you do a chaining method, do you want to return self to every single function, every single method? Or can you like just pick methods you want to do a chaining method with?
Yeah,
Does it
you
matter?
can you can pick them.
Okay.
Right. So if I had like when we were working yesterday with display user balance, maybe I probably don't want to return that, then you don't have to return self.
Okay.
Only if you want it to like, if you want to continue the chain, well, that method, that previous method, right? So like if this make withdrawal didn't do return self, that's okay. Right.
Okay.
I'm
Alright.
not trying to chain anything on it. So if I'm here and I run it, it still runs. The minute I try to do make deposit of 12, right? The minute this happens, because this doesn't return self, I'm going to get a none type error, right? None type object has no attribute make deposit, because it's looking for an object, an instance that has this attribute of make deposit, and it doesn't have that. So does that make sense? Okay. Ethan, what are we,
I'm still not connecting what the return self does and why that's so necessary. Like, because it just says return self, I don't quite understand what it does exactly.
yeah, absolutely. So when I am calling here, this Chuck make deposit, I have got an object, right? I have an instance of my user class of Chuck, right? Make sense? Here, then
Yes.
I am running a method on this user. And because it is a class user, I have access to all these methods, right?
Yep.
The way that my method identifies that it is Chuck making a withdrawal is the self piece. This self just says this instance of my user. In this case is Chuck, but specifically Chuck wants to make an amount, make a deposit. And I pass an amount, right? So this is how I identify the entirety of Chuck, right? I can do anything with self. Once I have self, I can say self.name, self.email, self.account, anything. Then I run something in my method and then I return self again. Again, I'm giving back that entire instance of Chuck. So that way, when I run the next one called make deposit, it is receiving that instance of Chuck and says, okay, Chuck has access to make deposit because it is of a user. It takes in that self, it alters the amount. Then it returns back that instance of Chuck. And then we go to make withdrawal and it continues because I am returning back that specific instance. It's how I know what user I want to like make a deposit or make a withdrawal. It's just,
Is there ever, in a case like this, is there ever going to be an example where you don't finish any of these items on top with return self? Or is it pretty much always mandatory that you have
No,
return
yeah, you
self
could
so
have-
you can apply it?
you can have something like this, right? Like display user balance. It takes in self, right? That's it. And then maybe I just print you or as, oops, sorry. Self dot amount. In the bank. I see all the errors. Okay. So here I just have a method that all it does is it prints this. I wouldn't necessarily need to return self. Somebody asked, is there a limit on how much you can chain? No, as long as they return self, you're fine. Now, if you were returning, like if you're doing, 100 or even like 10, then maybe you want to break that down for readability sake, right? Because it'd be hard to debug. You're like, which part is not working? But no, there's not necessarily a change. And this will come whenever we are really working with database stuff.
Is that right? If he said return self in here is working in the chain method as a store, doing the store like it's storing for next action.
It's not storing. It is, remember, whenever I run this make deposit, it's a method, right?
Yes.
And whatever a method returns, that becomes the value of that method.
Okay.
So here I am altering some sort, not here, I'm altering some sort of, values, in this case, account. But then what I'm returning is just that instance of self. So this becomes, like, you can kind of think about it. Let me annotate. Once this runs, it results into something, right? It goes and it does something. And then what it returns to me is Chuck. Because I'm returning self, right? This specific instance. So then it's like it's saying Chuck dot make deposit again, right? This runs. Then what this returns to me, because I'm depositing again, is self, which in this case is Chuck. Then it's just like it's saying Chuck dot make withdrawal. And so by us doing this and returning self, it's just this Chuck instance each time.
This makes sense. Thank you.
Yeah. Peter, what is your question, my friend?
Yeah, so I just wanted to confirm because Kevin was mentioning, the idea of if it's not changing any data in the instance, is it safe to not return self? But returning self, to my knowledge, is pretty much exclusively used for chaining methods, is it not? Or
Yeah.
like there's no real other purpose unless obviously because the idea is like, the whole like Chuck dot make deposit 10,000, that first chunk, as you said, when it returns self, it literally effectively disappears and gets replaced by Chuck, and therefore you're calling the next Chuck make deposit. So it's only if you wanted to ever like spit that object into something else. Yeah.
Yeah. Exactly. So that's something to know. And Kevin just asked, just meant if I display something, doesn't matter if I return, if I'm displaying. So like in this case, display user, I don't need to return Chuck, right? If all I want to do, and this is just as you are setting up your application, you will know what your method is doing, right? And so if I know that all I want this to do is display user balance, I don't need to return self, right? I don't need to necessarily do anything. I just want to do this. And so it's just having an understanding of what your method is trying to do. In this case, if I wanted to make a bunch of deposits, I could do that. And if I wanted to, in between each time, I wanted to display my balance, well, then I would have to return self. So it's just how you're building your application up. Kind of depends on, which ones are going to return self. Now, it's not mandatory, right? This idea of chaining method is not necessarily mandatory. It's just an option of something you can do. And in Python, there will be methods and functions that we use that we can chain. And we'll get into that a little bit later on, but there will be things that we can chain. So it's just this idea of, oh, this is returning back to me something, and I can chain something on top of that.
Makes sense, yeah. So it's the idea that basically like the display user balance is, you're thinking of it as like a capstone or an ending method to use, and that's why you, don't have to really return self there.
Yeah.
But
Yeah.
if
If
you
I
ever
make it,
wanted to put it anywhere in a chain, then
then you would have to return self. Yeah.
makes sense. Cool.
Cool. All right. So the second thing I wanted to talk about is association between two classes. So here I've got in my code, not that guy, sorry. I've got two things, right? So we have this Chuck that we just talked about, but let's say I work at a bank, right? Or I'm creating this. This is kind of helping you guys with users and bank accounts, but I'm a homie, so I want to make sure I help you guys. But let's say I'm creating a user, and a user can have a bank account, right? Because most people, I would assume, unless you, kind of forge and, hide your money in gold, which is cool. Good on you. But most people have a bank account, right? And so let's say we're creating this application where a user can have a bank account, and that's what our application is doing. Let's say we're Wells Fargo or something of the sorts. Well, what I can do is actually break it down to where I can have a user class and a bank account class. So let's say I do that. Now, note that unless you want to modularize this, they do need to be in the same .py file. There's some stuff on modularization that if you want to see, like, how do I have, a bank account.py and a user.py, you can go kind of do that. But for right now, what we're doing, let's just do it all in one file. But here I've got this class of bank account. Now, when bank account is created in the init, it takes in an interest rate and a balance, right? Let's say that it's super low because it's a bank, but we want to make sure interest rate and balance. That's what has to happen. In the same way, for a user to be created, we have to have a name and an email, right? Then there's some methods you can do with a bank account. You can deposit, right? You can withdraw, and you can display user info. Now, if we're looking at this, it doesn't really make sense if I'm just creating a user class and things that are specific to a user, right? If I'm creating a blueprint for a user, maybe I have a user, maybe I'm working for something else, and my user doesn't need to do like a make deposit, right? My user can do other things, and these things are specific to this bank account. So let's say we want to associate the two together, right? I can actually break out my code to where my user things are associated with specifically just my user, like walk or run or, I don't know, eat food. And then my bank account stuff can be fully associated with my bank account. Now, how do we do that? Here in my class user, I still have the same init, right? Self, name. Now I added these two little bits, right? And these two are my default parameters, where interest rate is by default 0.02%, and my balance by default is 0. So when a user is created, that is the default. If somebody passes in something, it can be changed. But if they don't, right? If they just want to say chuck@c.com, by default, the interest rate is going to be 0.02 and the balance is going to be 0. Cool. Then things are like normal, right? Where I have self.name equals name. I have self.email equals email. But then there's this last piece. It's this self.account. Now, because we are breaking our code apart a little bit more, right? We're just working with everything within my account was specific to, my user, where I had an account balance and I can make a withdrawal, make a deposit. But let's say my user has 2 bank accounts, right? Or multiple instances of bank accounts. We want to make sure we can split those two together. We're not kind of making some jumbled file. So therefore, that's where we introduce this bank account class. Now, we can say self.account equals an instance of my bank account. Remembering that in order for my bank account to be initialized, it must have an interest rate and a balance. Therefore, when we create this instance, we must pass it an int rate and a balance. In this case, I decided to put it up here. That way my user can change it. On the platform, you will see it down here. So if we're talking about association between classes, it does put it here. I think it's actually a little bit better to do it this way, because then we can control my interest rate, my balance if we start. So what this is doing is once this user is being created, once I'm creating this Chuck, It comes and it runs this method. It sets the self.name equals the name, the self.email equal to email, and then it creates this attribute called account. And what it does is when it reads this, it says, oh, before I finish this account piece, I need to go and make a bank account, an instance of this bank account. It comes down here and it creates an instance of my bank account associated to Chuck, where the interest rate equals interest rate and the balance equals the balance. And then the values are whatever we pass through. Cool. So now, because I am doing this, I can do a few things. I can now, before I keep going, are there any questions on this?
I had a question.
Yeah, what's going on?
So in here, if you're saying self.account is equal to bank account, right? Then self.account is this instance of bank account, and we are referring to bank account. If we have already in the bank account, we have defined the end rate and the balance, everything. Why we are again repeating that at the top in the self.account? If we are completely referring there, why we are again putting it here and also at the top on row 2, keep repeating these things that I have already explained and defined in the bank account?
Yeah, great question. So here, just remembering, like whenever we created a user, if I just want to create a bank account on my own, right? If I want to say something like some account equals bank account, then I have to pass in two things, right? In order for a bank account to be created, it must take in an interest rate and a balance.
Correct.
Correct. Cool. So here, up here, I am creating that instance. It's the same way that if I just said some account, right? In this case, I'm just saying self.account. So in order for me to create this instance, I have to pass it two things, an interest rate and a balance. The reason I'm doing it this way is this allows me, upon creation of my user, to change my balance and my end rate. If I didn't want to do that, then I could just I could take these out, right? And I could just do something like this, where interest rate equals 0.02. And this is what you'll see on the platform. And then like this, right? I still have to pass these values for right here. But if I do this, then by default, every account that is created has to have a balance of 0 and an end rate of 0.02. Now, if I do this, upon creation, I can say something like this. So when Chuck is created, not only does it get the name and the email, but now my interest rate, because something's passed through, it bypasses this default and puts 0.05 here. And then because, again, something else was passed through, bypasses this default and then puts 5,000 here. So now when Chuck is created, he also has an account that has 5,000 currently in it with an interest rate of 0.05. And so that's what all of those are doing. Does that make sense?
So that's working as a default placeholder kind of thing. And
This guy?
we can change it. Yes.
Yeah, so this is a default parameter. What this means is if I don't pass anything through, then by default, this is what it does. So if I'm creating Chuck and I just do something like this, I don't pass anything through, I just put a name and an email. Then by default, the interest rate goes to 0.02, and that's what it passes through here. And balance goes to 0. If I just want to put one of these, if I just want to care about my interest rate, I can do this, right? This overwrites my default, and so this interest rate becomes 0.05. This is just a default parameter for functions. And then my balance is still 0 because nothing was passed through. So these are just what we call default parameters. We kind of talked about this on Monday, but these are just default parameters that if something isn't passed through, right? If an argument is not passed through, this is what it defaults to. So that's why you have to have those there.
Okay. Thanks.
Yeah, of course. Cool. So here once I'm creating Chuck, and I'm going to give him a 0.05 interest rate, I'm going to give him $5,000. Once I am doing this, once I do this, and let's say I run this, what's going to happen is I am going to have this user called Chuck, right? Whose self.name is Chuck. The self.email is c@c.com. But then now I have access to this account right here. when we are associating two classes together like this, I like to think about it this way: is this account acts as a doorway into my other class. What do I mean by that? So here, if I were to say something like this, I want to print, let's say I wanted to get Chuck's balance, right? I want to see how much Chuck had. What I can do is I can say something like this: Chuck dot account. This is my doorway into my associated class, right? So now I have access to everything my associated class has, whether it's an attribute or a method. So here I want to say account dot balance. This account is the attribute that is the doorway to my bank account. Once I walk through that doorway, I have access to anything in this class. So now if I were to print this, we will get 5,000. Psych, will get an error. Let's see. Bank account is not defined. What do you mean bank account is not defined? I literally just ran this. Let's see. User check. See. Did I spell it incorrectly? Bank account, interest rate. Bank account.
Or is it because of the function open close parenthesis there at the end of bank account? No,
No,
on your, oh, your class user, no, yeah. I wasn't putting parentheses there, but for like your classes, you see how you put the open close parenthesis
Yeah.
after the word? I didn't put those.
you can,
Yeah, I don't know if that helps.
yeah, you can do either. Let's see.
Yeah,
I literally just ran
Yes.
this earlier when I was prepping for a lecture.
yeah, no.
Friends, let's debug. Okay, so it's saying self dot account, bank account, int rate,
Oh.
int rate, balance, bank account is not defined.
Is it because you don't have to sign them that way? If you just say int rate comma balance instead of int rate equals int rate, balance equals balance.
No, because what I'm saying is
And-
this int rate is just like make sure that these must be the
Definitely
same.
passes it to that, yeah.
Yeah. Int
Okay.
rate, balance, passing that through.
I'm also receiving same type of error. And do we need to return somehow somewhere, right? This bank account, return self,
Oh,
like,
It's because are you running the lines of code before you actually have the bank
You need
account
to put
class? Does
the
that
top.
mess with it?
No, I have a
Like
class.
even though,
Oh, it shouldn't. I ran it earlier
yeah,
today.
no, that's
it
true.
worked. Down
Yeah.
here, it worked just fine.
no,
Oh,
do we
yeah,
need
you're
to
right.
put it at the top?
Is it-
So what's happening? Sorry, friends. So what's happening is I'm trying to call bank account, but it hasn't gotten to this part of the code, right? And so it doesn't know what bank account is. So we all learned a very valuable lesson today. If you're going to do this, make sure that it is below your actual declaration of bank account. So declare your classes first, and then you run this. Sorry. Now it should work. Okay. So now it works. So now if I come here, sorry. So what was happening is when it was declaring user Chuck, right? When I was creating that instance, upon that creation, I was calling this class. But remember that code goes from top to bottom. And so what it was reading was line 1 through 23. It hadn't read line 30. So it was saying, I don't know what bank account is. I haven't gotten that far yet. So I'm calling on this class that so far doesn't exist. So if I am doing association between accounts, make sure it is below the declaration of both classes. Then you can, I'm just going to delete this because we don't need it. then you can call it and it will be fine. So if I run this now, you save this, run it. Then now I can see 5,000. I created check. When I created, I said the balance was 5,000. This account acts as a doorway into my bank account class, which is associated with my user. Then I can get anything I need, right? So I can say deposit even. So let's say I want to say something like this. Chuck.account.deposit 5,000. So if I do this, because deposit is part of this class, I have to use the doorway to get into it, my account, right? Which is up here. And so by doing that, I actually don't need any of this material, right? A user doesn't need to do that. That is just associated to my bank account. It can make a deposit, it can make a withdrawal, and it can display the user info. So if I were to save and run this, I deposit, oh, I didn't do the balance. Goes 5,000. I deposit another 5,000. It goes to 10,000.
Hey, well, quick question. So when you create the instance of Chuck,
Mhm.
you are by association, you're basically creating another instance of bank account.
Yeah.
Through the account attribute, right?
Yeah.
What name does the bank account instance take when you do this?
So this, in this specific instance, it doesn't have a name, right? The only attributes of a bank account instance is that it is an int rate and has a balance.
Can you give it a name?
Let's see something like this. Let's say, no, because it won't know. No, I mean, you could, if you wanted to, you know, self dot name equals name. And then maybe now whenever, you'd have like a checking, right? This one's a little bit flawed because this is just an association between a dependent class. So in this case, bank account, in order for it to be created, well, not necessarily in order for it to be created, but what I could do is something like this, right? Like, if I just wanted to create just a bank account, I could say checking equals bank account, checking, 0.02, 1,500, right? Now here, if I run this, I can create a bank account, right? This will create a bank account and I can say checking dot name. It just won't be associated to a user. So now if I run this, there's an error. Oh. It's because I'm trying to call Chuck and there we go. Now if I were to pull my terminal up, do clear. So I can still create an instance. 6 we're given. Oh. Híjole. Sorry. Name equals name. Now this should work. Psych. Okay. Sorry for the long-winded. I just had to make sure that now my bank account, what happened is because I added this needed argument then whenever I create an instance, I could have just commented Chuck out and it probably would have made it easier. But in this case, I am creating an instance of a bank account, right? And I'm calling it checking. And we can see that it prints out checking, right? I create that instance. It just doesn't have an association with my user, right? I don't have a user necessarily on here. That makes sense. So if I want to add a name, like I can have a bank account on its own, or let's say I wanted to create some sort of association, I can do it like this. Now, I wouldn't get so caught up in class associations because when we get to our databases, we're going to create what we call like relationships within our databases. And we're going to use things like foreign keys in order to create a relationship. So the way we would do this coming in the future is we are going to have basically a database of users and bank accounts, right? So let's call this you. And then I will have a declaration of some relationship, probably like this, what we call a one-to-many, where my user can have many bank accounts. And then there will be an association there where it has like a user ID. And so this whole idea is that we're just kind of getting used to, I can create this account and associate it to my user this way. I can also create an instance of bank account on my own if I wanted. But the biggest thing to take away from this association of classes is that when I create a user and I create this account piece, I can use this dot account as a doorway into my bank account, right? And I can do things like deposit, like display account info, like withdraw by using that doorway of dot account. Does that make sense? Any questions on this? You can put a 1 in the chat if this makes sense. Or 0 if it does not.
I do have a side question.
Yeah, what's going on?
In terms of the way you pass the arguments in with the equals, I was curious, is that a way to, like, obviously, or are you just doing it just because it's a little easier to read out, or is there a specific reason for using that? Or
Yeah. So 2 ways, right? I could either just type in bank name, int rate, and balance equals balance, right? I could just do this.
Yeah.
And if I do this, then the order is particular, right? So
Okay.
this bank name will automatically go here. So if I were to accidentally do the wrong order, then that's an issue. If I do it the other way, it doesn't matter the order. It's going to look here, is this balance. So let's say balance is like this. It's still, although this says name, balance, int rate, and this says name, int rate, balance, it connects this name right here to whatever this is. And then so this balance will go to balance. So it's just like a more surefire way if you're looking for like that issue.
And is that I guess also an easier way around, like, say if you had defaults, which I figured out my problem, but at one point I had defaults for like all the values for some validation checking and stuff like that. Would that be a way to work around having to, because obviously when you have defaults, it does have to be in their very specific order. So just assigning like this, like say if you had like a default on your name here or something, and you didn't want to fill that in, if you just put balance equals balance and int rate equals int rate, would that just avoid name and let that default properly? Just I was basically having a trouble. Yeah.
You would still have to have name. So like if I just had this like this, yeah, but these have to be at the end. So if you do like a default, same thing like here, they have to be at the end.
Oh yeah, but I had a case which, again, I worked around it because I realized it was sort of dumb of me, but I had it where basically all of the values had defaults at a point, and in that point, then it's like it has to be in that order. And I was trying to avoid having to fill in like the first 2 values without having to like shift everything.
Sure.
So I didn't have to do that. So would that be a way to work around that?
So for this one, but this would be like the way you would work around it is if you had this here, you would say name equals Or no, not sorry. You'd say something like this, like upon declaration, you would have to say, like,
Yeah.
this would automatically associate, bank name. That's how that would work.
Yeah. And say you have like a default for name or something for whatever reason, you could just skip that if you just put email equals bank name equals. Okay, cool. Yeah, I was just wondering about that.
Yeah, so you could do something like this too. This will do the same thing, but they don't have to be in the same order. So
Yeah.
totally
Nice.
up to you. Cool. So we're going to talk a little bit about pillars of OOP. One thing I do want to point out, and something we haven't necessarily talked about, is when declaring a class, this is the proper name to associate between a class and a method, is by, I know we've been doing a lot of snake case, which is awesome. And that is what by default, kind of how you would like industry standard for a method. If you're doing a class though, it's all, I think it's called Pascal. No, not Pascal. I can't remember what there's so many.
Camel case.
Camel case. Yes. Thank you. Camel casing, where you have, it starts with every new word starts with a capital letter and it's all, combined together. That's how you do it with a class. So that is kind of industry standard in Python. If you're declaring a class name, it's this way. You don't use like an underscore to do camel case or to do snake case. So one thing I did just want to point out, the last thing I want to talk about is the 4 pillars of OOP. Now, again, this is a little bit more just theory. And the reason we do this is because something, especially coming out of a boot camp, right? If you don't have a CS degree, oftentimes they want to just make sure that you understand, what you're doing and sort of some paradigms of code. And so this 4 pillars of OOP is pretty important because, it's just understanding what is going on and whenever we are building an application, what actually is happening, right? And so in an interview question, they might ask you, what is inheritance or what is encapsulation or polymorphism? Can you explain that to me? And so that's why we wanted to touch on these. I'm not going to go into super deep depth because for the rest of the program, we're not necessarily, 2 reasons. For the rest of the program, we're going to touch all this stuff, but we're not going to be like, oh, this is an example of inheritance. I might occasionally, but this is something that, you're going to have to study a couple times because even if I talk on it for 5 minutes each one time, you're going to have to continue to do that, especially for your interview prep. This is something important to know. So just remember, if you are prepping for some sort of interview and part of it says you have to do OOP, you should know the 4 pillars. And the first pillar is called encapsulation. And that's basically what we're doing, right? We are using classes and coding blueprints to define what our objects are and how they behave. So in my code right here, when I am declaring this user that they've got this name or this bank account that has this information, and then it has what it can do. It can deposit, it can withdraw, it can display account info. That's what we call encapsulation. And that's what we're doing, right? And so I look here, I've got this coffee, it's got this init, right? It takes in self and name, and it has some methods that you can do. That should be pretty simple to everybody because that's literally what we've been doing this entire time, right? It's just now the fancy word is called encapsulation. We are encapsulating attributes and methods to our class. We are defining a class and saying, this is what belongs to that class, whether it be an attribute or a method. Now, the next one's a little bit harder to grasp, in my opinion, but I have a pretty good example. And this is what we call inheritance. So inheritance is the idea that we pass along attributes and methods from one class into a subclass. You might hear it be called like a parent class versus a child class. And so what we do, instead of having to rewrite all the code, we can actually just inherit from another class. What do I mean by that? Well, if you guys remember back on Monday, we had talked about and we did employee, right? We had Dojo's Tacos was my company and we created an employee. And somebody on Monday asked me, well, what about a salesperson? What if a salesperson is different? That's a great example of something that will inherit employee. What do I mean by that? So let's say I'm creating this class called salesperson, right? I have this generic class called employee that has a first name, a last name, a department, a salary, and years at company, right? Every employee from my company has these specific things, right? They can have a salary raise, they have a work birthday. These are generic to every employee. But let's say that I have I can break it down a little bit more. And let's say I have a salesperson. I want to create an instance of a salesperson. Let's say I have a sales team. If I want, instead of having my salesperson have to have first name, a last name, a department, a salary, and years at company, because everybody in my company has that, what they can do is they can actually inherit those values from another class. In this case is employee, and employee becomes the parent class, right? What happens then is I still have this def init, and it's still, in order for a salesperson to be created, they still have to have this information, right? If I'm just going to create a salesperson by myself, because I'm inheriting this employee stuff, I still have to give it, right? I still have the requirements of what it takes to create an employee. But instead of me having to rewrite all that, I can use what we call a super. And what a super will do is it will actually run the init and of the parent. So I don't have to rewrite all of this. Here you can see that it passes a last name, a salary, department, years at company. But I don't have to rewrite all that information to create a salesperson. I run the super init and I inherit this entire init function right here. So when I give it a first name, it has a first name, right? I have access to all of those attributes. But what's really cool is A, I don't have to rewrite all that. But B is I can add on additional things that are unique to my salesperson. In this case, I created a commission rate. Let's say they got 15% of commission. So what's cool is not only does the salesperson inherit all these attributes, but it also inherits all the methods. So every salesperson still has a work birthday. Every salesperson still can have a salary raise. They can have, and those are the only two methods. My salesperson can also have unique methods that are only to this salesperson. In this case, let's say they had a sales commission, right? So they can make a sale. When they make a sale, this method takes the sale amount, multiplies that by their commission rate, and then says, hey, you made blank commission on that sale. And so this is an example of inheritance, right? My salesperson inherits everything from my employee using the super right here, but it can still have unique values and unique methods. It has access to every method in my employee. This is my base sort of class, but my salesperson can actually have other unique things. And I can do that throughout, right? I can create like an HR person. I can create management. Maybe their pay scales different, right? They have all these different methods, but they all, at the end of the day, have a first name, a last name, a department, a salary, and a years at company. So that is what inheritance is. I am using, instead of having to rewrite, I'm using all the values from a parent, in this case is employee. Any questions on inheritance? Does that make sense? Can you put a 1 or a 0? Again, these are things that you will continue to practice, but, and when we get into Flask, we might use some inheritance for sure. But especially if you get into like Java or a strictly typed language, you might see this a lot, right? You might inherit from a larger class. You might be inheriting from something else. Okay. So the third pillar is what we call polymorphism. What that means is, many forms, right? I can alter, let's say I have, let's take this employee example. Right here, I have a salary, right? And then I have a salary raise. Well, my salesperson might have a def salary raise that actually operates differently, right? With polymorphism, maybe my salary raise is like, let's say I had like a tracker. I'm not going to actually build it out, but let's say I had like a tracker, and if I hit X amount, then, I had, if hit 50% of goals, 3% raise. If hit 75% goals, 6% raise. If hit 110 plus, 85, whatever, 13% raise. Polymorphism allows me to have methods that are inherited, but can be changed, right? Depending on the class that is doing it. So in this case, My salesperson might have a different salary raise than maybe an HR, then maybe like a manager, then maybe like janitorial staff. And so that's what polymorphism is it allows, it says, hey, although these inherit from the parent class, it can also be changed. I can change that information. And then the last one is called abstraction. This one, if you're reading it, kind of seems harder than it actually is. Abstraction is just an extension of an encapsulation, basically, that says you don't need to know everything about what's going on. It can just work, but you don't necessarily need to know everything that's going on in this. The best way to think about it in a real life abstraction kind of example would be a car, right? I would think that most of us can drive a car, right? Maybe some of you don't, maybe you live in a city, or maybe you just have a fear of driving. That's okay. But most of us drive a car. Most of us probably don't really know how a combustion engine works, right? Maybe you have some understanding, but maybe you don't necessarily know how it works. I don't know most of you, but maybe I would argue, if anybody, maybe some of you can, but very few people in this class could actually, if I just gave you a bunch of parts, build an engine from the ground up. Abstraction works that way. I don't necessarily need to know how driving or how an engine works in order for me to use an engine, right? Abstraction means sometimes I don't need to know how something works in order for me to use that in the parent class. So from there, that's like an example of, you don't necessarily need to know how the engine works in order for you to drive the car and to use the car. You can dive in and maybe learn about it if you want, but you don't need to know. That's what we call abstraction. So just reminding you, encapsulation is what we're doing. That is assigning attributes and methods to a specific class. Inheritance is taking attributes and methods from one class and applying it to another one, right? Giving it access. Polymorphism is saying, hey, even though sometimes there's the same method, I'm going to alter it depending on the class that is inheriting that. And then abstraction is, although I don't know what is actually happening, it doesn't necessarily need to, I can still utilize those different methods. So those are the 4 pillars of OOP inheritance. Here's another kind of good talk on inheritance and kind of walking through that, if you guys are interested in that right there. And talks about super, right, which is what we just talked about as well. And so any questions on the 4 pillars? Again, it's not necessarily huge in where we're moving next, but that will be absolutely something that you will want to know for your technical interviews when you guys get there.
I have a question.
Yeah.
I was curious, our today's example, user and bank account, in which pillar they are falling in. I was thinking, okay, it can be inheritance, right? Or maybe different.
So I'm not inheriting anything. So these, unfortunately, these would probably just be encapsulation, right? Because
Yes.
I'm assigning attributes to this class.
Correct.
And I'm assigning attributes to this class. If this was going to inherit something, right? If let's say a bank account was going to inherit for some reason, well, let's go back to this pillars one. Here, employee, I'm using encapsulation, right? I'm just assigning some attributes to this employee class. Here, I have to, in the parentheses, declare the class that I want to inherit from. When that happens, then I get access to everything. In our thing today, we just have 2 instances, two classes that are separate, but I can call and associate them together, but they're not necessarily inheriting from one another. Bank account is not getting a name or an email, right? It's not getting that information. It just has a name in the sense of like bank name. That should probably be defined differently. Right? So they're still different. I'm just creating an association, but they would be using just encapsulation, really would be the only, and maybe at the end of the day, if you were using deposit, right, you might use abstraction. Like, I don't need to know how deposit works. I just want to be able to deposit stuff. You could use that there.
Understood. Thanks.
Cool. Okay. Derek,
Just don't read chat. Just don't read chat.
your chat is insane. Turn over the course of the code. Very meta well. Okay. I'm not a mechanic. Absolutely not. Who's coding juice are you talking about? Peter talks about. Okay, you guys are insane. Okay. All right. Any questions on actual code instead of talking about other things in chat? Any questions on anything we did today? How do you guys feel about what we did today? Okay, you feel good. 0.5, that's okay. You're getting it. Cool. Awesome. Well, that's all I have for you guys today, friends. Just remembering, continue to work on your assignments. The users with bank accounts and bank account, those are your two heavy hitters. Make sure you hit those. We did talk, I did kind of share with you. I mean, I kind of did users with bank accounts for you. So, you know, nice. So make sure that you can do that. But there is a Sensei bonus, allow a user to have multiple accounts, update the methods so that the user has to specify which account. That's a good one. When you see these Sensei bonuses, just know that this is not necessarily, you don't have to do it, but it is like if you're wanting to do a black belt, which is our highest, you know, kind of belt, these are great tools to like start getting you used to what black belt material will be. And then one other thing I do want to point out, it was also in Web Fundamentals, but I did see it one time in Discord, is once you're done, once you submit this, if you are very confused, there's a check solutions right here to where there is an entire video walkthrough of how, you know, here's the actual code, but then here's an entire video walkthrough of how to do that. So once that's submitted, here's an 8-minute walkthrough of how we would build that out. I don't know if Adrian did the Sensei bonus on the video or not, but probably not. But that is there as your, you know, what I always say is don't just go ahead and check the solutions. You're not going to be a good developer that way. Make sure you actually try, right? Do your best and then go and say, well, can I make it better? Right? That's what the videos are for. Can I make my code better? Or if you're really stumped on something, that's okay. So other than that, friends, oh, last thing I do want to talk about is overriding and polymorphism. Overriding is basically just doing kind of the same thing with polymorphism, is saying like, oh, I want to redefine this method. I'm going to override that functionality and redefine it. So these are polymorphism says that they can be different. Overriding is like, I'm actually fully going to override that. Here's a great article just kind of on that. Overriding and polymorphism, talks about millionaires and bills. It's pretty interesting, pretty good. So other than that, I would do dojos and pets. If you can, do it. This is a great one. It's a great thing to understand this. And that's it. That's all I have for you guys. I hope you have a wonderful night.